left hydraulic system's pressure begin to build. This will normalize between 2,800 and 3,350 psi. Once the left engine is running normal and stable, press the spacebar key to proceed. We'll now repeat the process for the right engine. Once again, the engine is started by moving the throttle from off to idle, or in this case, pressing the right control plus home keys. As with the left engine, monitor the instrumentation as the right engine spools up. Also watch the right hydraulic system pressure to normalize. Once you have both engines running normally at idle power, you can do a flight controls check to test the responsiveness of the controls to stick and rudder input. Test the speed brakes and flaps. Press the spacebar key to proceed once everything checks out. With both engines now running and powering the left and right AC generators, we can turn off the APU generator on the electrical panel and then the APU itself on the throttle panel. Okay, now we'll power up the control display unit, CDU, and the embedded GPS INS IGE systems. This will begin the automated built-in test, BIT, and alignment processes for the navigation system, which you can monitor on the CDU display on the right console. Uncage the standby attitude indicator, SAI, on the front dash. To do this, turn the SAI cage knob to the left by rolling your mouse wheel down over the knob. Once uncaged, roll the wheel back to set the SAI aircraft indicator level on the horizon. Turn on the multifunction color displays, MFCDs, by left-clicking twice on the power switch for each display. While we are waiting for the CDU bit and IGE alignment to complete, we can continue the startup sequence. Turn on the Central Interface Control Unit, CICU, on the Armament HUD Control Panel, AHCP, on the front dash. This will provide essential user interface controls to numerous aircraft systems, including the left and right multifunction color displays, MFCDs. The MFCDs are now on. In a few moments, they will display the Data Transfer System DTS page, which we will use to upload navigation and weapon configuration data saved on the data cartridge from the mission planner. Now, set the Integrated Flight and Fire Control Computer IFFCC switch to the test position by left-clicking once. The IFFCC provides weapon release calculations, attitude control, and HUD indication. In test mode, the system will run a series of automated bits, which you can monitor on the HUD. Press the ENT Enter button on the upfront controller UFC to initiate the IFFCC bit. This will take approximately 1 minute. While waiting for the IFFCC to undergo the bit and the IGE system to finish aligning, let's set up our flight control systems. Set the left and right yaw and pitch SAS channels on the SAS panel on the left console to on. Now press the TO trim button to set the flight controls for takeoff trim. Let's upload data from the data cartridge.
Pull up,
Low
pull up.
haul on the left MFCD by pressing the option select
Altitude,
button.
altitude.
10. The DTS will take about 15 seconds to transfer the data from the cartridge to the jet. During this time, all the asterisks accompanying each data type on the left side of the displays will disappear. When all the asterisks reappear, the data has been transferred successfully. Once the data is loaded, set the right MFCD to display CDU data by pressing OSB 13. This way you don't have to take your head down to check CDU indication. The IFFCC bit is now complete. As you can see on the HUD, the exit function is currently pointed to by the HUD cursor. Press the Enter key on the UFC to exit this HUD menu. The IFCC is now displaying the ground bit menu on the HUD, where you can run a number of other bits if necessary. To exit out of this menu, press the Select Rocker key on the UFC down repeatedly until the HUD cursor points to exit again. Then press Enter to exit this menu. The IFFCC is now displaying the main menu on the HUD, where you can set up various indication and weapon release parameters. Let's take the IFFCC out of test mode and set it to on by left-clicking the IFFCC switch one more time. Let's set the left MFCD to the Tactical Awareness Display TAD page by pressing OSB 15. Now load up the flight plan. Right-click the steer point switch on the AAP panel to set it to flight plan. This will set the flight route to appear on the TAD display. With our flight and navigation systems ready, we can prepare some of the combat systems for the mission. Set the countermeasure signal processor mode switch on the CMSP panel to standby. For a combat sortie, you may want to review or create some countermeasures programs, but that is for another lesson. Now set the 4 system select switches to on, middle position. Next, set the Joint Tactical Radio System JTRS switch on the AHCP to on. This will provide power to the Situational Awareness data link saddle. With the IGI aligned, let's select CDU nav mode by pressing OSB 9 on the right MFCD. Select the EGI as the primary navigation system on the Navigation Mode Select panel. Next, arm the Enhanced Attitude Control EAC switch on the Low Altitude Safety and Targeting Enhancement LACD panel on the left console. Note this switch is hidden under the throttle, so you may have to shift your view position to see it, but it is still clickable with the mouse. Turn on the radar altimeter. At this point, we are ready to taxi to the runway. Set the anti-skid switch to on. Now turn on the nose wheel steering by pressing the pinky button on the control stick or insert on the keyboard.